Okay, hi everyone. So we're going to go ahead and get started with U8 Packet 2 next lesson. We're going to be learning about inscribed angles, intercepting a diameter, and overlapping arcs in this lesson. You will be able to determine which each one of these components are by the end of it. Okay, so let's get started with the notes. An inscribed angle is an angle with its vertex on the circle with two sides that are chord. So in this case, we have point B on the other side of the circle, and so we have angle ABC. It's inscribed. It's not going to the center, it's going to the other side. An intercepted arc is the arc that lies between the endpoints of an inscribed angle. So the endpoints of this angle are A and C, therefore the arc is arc AC. Okay. The measure of the inscribed angle is equal to half the measure of its intercepted arc. So looking at that, let's use some numbers. So for example, if I was to say that the arc measure here is 100 degrees, then its inscribed angle is half of that, meaning angle ABC would be 50 degrees. This is different than if this angle was from the center, which in case it would be 100 and 100, but since it is inscribed, it is half. Okay, so let's look at another type of inscribed angle is called intercepting a diameter. So if an inscribed angle intercepts a diameter, then it is a right angle. So here I have a diameter of BC, right? And my intercepted angle is BAC. Notice how the ends touch the endpoints of the diameter. Therefore, this is going to be a 90-degree triangle. Now, when I say that, I want your brain to start thinking of trig components, thinking about Pythagorean theorem, special triangles, things that we've discussed when it comes to right angles, because they are probably the most special type of triangle within geometry and math as a whole. You know, aren't they special? It's so great. Okay, so next we have overlapping arcs. Now, it looks complicated, but it's incredibly simple. So it reads, if two inscribed angles intercept the same arc, then the angles are congruent. So let's look at what they've given us. They said measure of ABD. So A to B to D has its arc of AD over here. And then it's telling me that this angle is going to be the same as measure of angle ACD. So have A to C to D. And the reason they measure the same is because look at how they share that common arc, right? So if the arc is shared, then the angle is also the same. And I like to liken this to a stage. So if the arc AD is a stage, right? And these are lights at point B and C, those lights have to populate the entirety of the stage in order for it to be lit properly. Therefore, the angle of B and C are the same. All right, let's go ahead and do some examples to solidify this learning. We're going to start with number 1, very simple. We have an inscribed angle, and I notice that its arc measure, that's not what I wanted, is 62 degrees, which means its internal measure is half of that. So 62 divided by 2 is 31 degrees. Okay. For question 2, they reversed it. They gave us the angle on the inscribed angle, which means we have to figure out its corresponding arc. And this time we are going to double, that value. So measure of DGF is going to be 226 degrees. Okay, 3 looks a little different because 3 is talking about intercepting a diameter. First, let's recognize our diameter. We have PR is our diameter because it's running through the center point. And I notice that my inscribed angle of PQR has endpoints at the end of that diameter, means this is a 90-degree triangle. So very simple, PQR is 90 degrees. All right, I am going to skip. Oh, actually, no, you know what? I am going to do 4. 4 is interesting. So for 4, I have this inscribed angle ABC, which means that the arc measure is going to be times 2 that. So 47 times 2 is 94 degrees. And the question, though, is asking me for measure of arc BC. I want to know this arc. So all I'm going to do is a little bit of algebra. Because this is a half a circle, and I know it's a half a circle because I have the diameter here. If this is 94, I know that this whole thing is going to equal 180 degrees, right? Because half a circle is 180. All I need to do is subtract 94 from 180. So 180 minus 94 equals 86 degrees. And that's my answer. All right. I'm going to skip 5, let you do that one, and then let's do number 6 together. So 6, again, it seems complicated, but it's not. So we want to know the measure of RST and RUT. So let's place those. So RST is here. Its opposite arc is RT. And then RUT is here. Again, they share the same arc. Notice the endpoints. They share the same arc. So we want to know what is the measure of these angles, and we can find that measure if we find the arc measure. So we can find the arc measure fairly simply because I have this degree measure, this degree measure, and this degree measure. So if I added all of those up, I have 64, and please write this down, you should do the work. 64 plus 139 plus 75 is 278 degrees. So the yellow part in highlight is all 278. And I know a circle is 360, so all I need to do is 360 minus 278. And I get 82 degrees. So that's not my final answer. If the arc is 82 degrees, remember from the previous one, its inscribed angle is half of that, which means this is 41, and this is also 41 because these are the same measure because they share an arc. Okay? All right, last one I'm going to do on this page, and then I'll actually start another video because I recorded before and I messed up and it was like 20 minutes of work lost. Anyway, so number 7, I have another inscribed angle here at CDE, excuse me. And I have its arc. So CE is 158, which means its opposite inside angle is going to be divided by 2. So 158 divided by 2 is 79 degrees. Well, I also happen to have an expression here, and they're asking me to solve for x. So if this is 79 and it's 8x minus 9, I set them equal to each other. So I add 9 to both sides. I have 8x equals 88 and x equals 11. And that's it. You're done. And I'm not done with the examples here. I will pick up on this page. We'll do a few more. And then the next lesson will be inscribed quadrilaterals. So take a break, do what you need to do, or attempt this page by yourself. I'll see you for some select examples on this one. Bye.